out of both, so what we have now, Artur, is this term and this term. And we're pulling x minus 2 out of both of them, and something has to be left for multiplication. So it's the 1. This can actually get trickier in a way that Jordan just mentioned, and I want to do an example of that in a sec. But for now, real quick, I want to do one more of these. Okay, and Artur, this will either clarify what you just asked or make it more confusing. But either way, I'm going to ask you to take the lead on this one. What is the biggest thing you can factor out of the first two terms, Artur?
X squared.
X squared is it, yeah. Can't do anything with the 3 and the 2. So that leaves me with 3x minus 2, correct?
I understand why you can't put 3x squared on the outside and then an x on the inside.
Because of the 2. We can't, 3 and 2 don't have any factors in common, except for 1.
Alright.
Yeah, so the 2 stops us from doing that. Now, one thing to think about, once you find whatever's left here, in order for this to work, you have to be able to pull the same thing. You have to be able to have the same thing left out of these two terms. So what can you pull out of minus 9x plus 6, that will leave you
3.
with 3x plus 2? Well, if I pull 3 out, I'm going to have a negative left. So what can I pull out? You're so close. What can I pull out of this one for it to work?
1.
Pardon?
Negative what?
Negative 3.
Wow.
I have to pull a minus 3 out in order to have positive 3x minus 2 left in there. Thank you, Eliza. I didn't think I was asking that question well, so I was so happy you saw that.
Well, no, I thought you were talking about the first one, that's why.
Oh, no, just I was talking about the second 2 at that point. Okay, now...
So you're giving us all examples of when you can pull it out.
Yes. And you have to have the same thing left here and here for this to work.
Okay, but you say that can't always help.
Correct. On the ones on the homework tonight, if it says factoring by grouping...
Wait, wouldn't you have negative 2, and then would you have...
If you factor a negative 3 out of positive 6, you have negative 2 remaining.
No, that's not what I was talking about. Never mind. You can't, because they're not like terms, that's why.
Okay.
Wait, can you...
Yes, ask me anything about it. Your questions are often better than my explanations. You good?
As far as it gets.
For the factoring by grouping, yeah. For this test, it won't be bad, because I will say factor these by grouping. There is some of your homework tonight that says factor by any method, so you'll have to check if this will work.
Can you give us our homework, then we can write it down?
No, there's one more thing I've got to do here. Still. There's one more type. Okay, that's it for factoring by grouping, but I'm going to show you one more thing. Some of you will get it quickly, some of you will hate it.
Wait, how come there's less writing on the board and usually there's so much writing? Because usually class went by really fast. And
It did. Follow me back, Jordan.
There's like nothing.
You weren't ready yet.
Okay. Alright, now for this one. How do I want to call this one? I'm going to call it fake quadratics.
Why fake?
Well, because they're not really quadratics. But they behave like quadratics. They're posers. They're poser quadratics. Okay? Posers. Here's what happens with a... Let's do an example of a real quadratic first.
Wait, that's gonna confuse.
Well, hang on. Let's say this hopefully will help. If I had...
Is this part of our homework too? This.
Yes.
The same. No, the real part.
Yes. If I have x squared minus 11x plus 18, this is a real quadratic, how could you factor that? And I'll give you a big hint. This is one where you look to see what multiplies to 18 and adds to negative 11.
So 6 and 3? Oh, no.
What multiplies to 18 and adds to negative 11? Positive or negative?
Negative.
Negative. Okay, so this would factor to x minus 2, x minus 9, and you would call it a day, right?
Nope. Yeah. Sure.
Yeah, that would be fully factored.
But then what do you...
Here's a fake quadratic. Okay, here's a fake quadratic. If I give you one that looks like x to the 4th minus 11x squared plus 18, there's a rule that works here. Okay, here's the rule.
Oh, it's because the square to the 4th.
Yeah, if the middle number here, if the middle exponent, the exponent of the middle term...
Did you take out an x squared?
Oh, I can only do that from the first two, so that wouldn't help. But here's the rule. Let me say it from beginning to end first. Okay? if it looks kind of like a quadratic, and the exponent on the middle term is exactly half the exponent on the first term, you can treat it like a quadratic, and it'll factor like this. I can make this x squared minus 2, x squared minus 9.
Wait, is this for the x to the fourth?
Yeah, because if I were to FOIL this, I would get x to the fourth minus 2x squared minus 9x squared plus 18. But that only works if this middle exponent is half the size of the outer exponent. Then you can use this, all the rules you learned for quadratics will also work here. Incidentally, is this fully factored now?
Sure.
Is there anything else we can do? Does x squared minus 9 look like any other rule we learned?
Oh, nope.
Yes, it's a square.
Difference of squares.
Yeah.
Close. So this can actually be further factored to x squared minus 2 times x plus 3, x minus 3.
But why would you want to do that?
Well, if the directions say fully factored, you kind of have to. So all the rules you learned about quadratics could also apply. And I'll give you another one here. If you had... Wait, okay. If, for example, you had... No, I don't want to do that one. Okay, 16x to the fourth minus 1. And I said to factor that further.
Wait, is this fake?
This is still a fake quadratic, yes. So are there any rules of quadratics that apply to this one? Big hint, what do we do for x squared minus 9?
You do the difference of squares.
Difference of squares. Is 16x to the fourth a perfect square?
Yeah.
What is its square root?
4x to the second.
4x to the second. Very good. And is 1 a perfect square?
Yes.
Yes. So this is 4x squared minus 1 times 4x squared plus 1. Okay? Now this often happens with these problems, and they're often set up to do this. What about 4x squared minus 1 here? Is 4x squared a perfect square?
Yeah.
2.
Yes, 2x.
2x minus 1, 2x plus 1.
So 2x minus 1, 2x plus 1 times 4x squared plus 1. Okay? Do we have a sum of squares rule?
Yeah.
No, we do not. This is fully factored. We have a sum of cubes. We don't have a sum of squares. So this is now fully factored.
How do you have some
These are ugly.
Where do you say cube?
There are no cubes there. I'm just saying that don't mix it up with, I think I just accidentally
These are not pretty.
caused that to be confusing. Yeah, you don't have a sum of squares rule, but if you had cubes, then you could keep going, is all I meant. So remember last night, Amanda, we did the a cubed plus b cubed?
That was normal.
Okay, questions on this?
No.
Here's the problem with the fake quadratics. I don't have time to do an example of every type of quadratic we've ever done. So you'll probably hit some surprises in that section of the homework. Good news about the homework is they're all in a section marked quadratic form. So that'll work.
The page.
The homework is, give me a minute.
Wait, what's that?
Find fastest here.
So are these enough notes to help us?
Hopefully. This is page 349, 42 to 66. Even is the homework. Okay? Page 349, 42 to 66 even.
Oh, should I turn this off?
Yeah, go ahead and kill it.